All right, so we're going to look at what's called combinations or selections. Now, prerequisite knowledge for this is arrangements or what's called permutations. Otherwise, this won't make any sense. So I'll put that link below. Here it is. It says if you want to know how many ways you can select R objects out of N objects, you would say N choose R equals N factorial on R factorial by N minus R factorial. Okay, so let's explain this in more detail. Again, we want to really understand why this is the case so that when we use it, we can sort of feel it, why it's true. So the best way to explain it with is an example. So here it is. How many ways can two elves be selected from 5 applicants for Santa's workshop? So clearly, Santa's workshop is a very competitive environment. He's getting lots of applications. He's getting 5 applications, and he can only select 2 elves to be in his workshop. So let's have a think. How many different combinations of elves could he have, or how many different ways could he select 2 elves out of 5 elves? So let's do that. First thing we're going to do is we're going to show the elves here. We've got very creative names, A, B, C, D, and E. Okay, and Santa's only got 2 positions. So we've got our 2 positions here that the elves can be assigned to. Now, I think you would agree that there would be 5 options for the first position in the workshop. Because there's 5 applicants, you could select 5 different ones for this position, assuming they're all equally qualified. Anyway, don't worry about that. And you would agree then that in this second position, you can only select from 4. So you would get 5 multiplied by 4, which is 20 ways that you could arrange 5 elves into 2 positions. Now I'll say that again because my language is important there. 5 elves arranged into 2 positions is 20, but we're not interested in arrangements. We're interested in combinations or selections. So what that means is we actually don't care about the order. Selecting elf A and B is the same as selecting elf B and A. Doesn't matter which position they're in if you're selecting for two positions here. A and B is the same as B and A. So we need to basically eliminate all the double ups, and that's what this is all about. So let's have a think. Let me show you all the different combinations, right? If we started here, if elf A got the first position, then maybe elf B got the second position. Okay, then we can cycle through them. You could have elf A in position 1, and then you could have elf C, A and D, A and E, and then you cycle through them. Change this first position to B, and then you get B and A, but you notice we already had A and B. So this would be a redundant pairing because we've already had it. Let's cycle through them anyway. B and B you can't have because you've already selected B. B and C you can have. B and D you can have. B and E you can have. Okay, again, C and A, but we've already had A and C before. So basically we need to start working out how we can divide through or eliminate the double ups. Okay. I encourage you to step that out and work out how many combinations there are. There is 20. I can tell you that there's 20. The tricky part here is we need to get rid of all the double ups. So what we're going to do is we're actually going to divide through by R factorial. Now in our case, R is 2 because there's 2 positions. And this should make a bit of sense. I want you to sort of understand why this makes sense. You need to divide through by the number of ways that those positions themselves can be arranged. Remember, A and B is the same as B and A. So we're going to need, in this case, to divide through by 2 factorial because those positions themselves can be arranged in 2 ways. So we need to divide through by R factorial. Aside from this R factorial, this is the same thing as the arrangements formula that we looked at. So that the reason the R factorial is here is to cancel out double ups. So if we look at the formula, just applying it to this problem, 5 choose 2 is 5 factorial on 2 factorial by 5 minus 2 factorial. Okay, once you've worked this out, the number crunching isn't too bad. 5 factorial is 5 times 4 times 3 times 2 times 1, divided by 2 times 1 times 3 times 2 times 1. I trust you can work that out. You'll get 60 over 6, which is 10, which should make a lot of sense because there's 20 ways you can arrange the elves where the order, where you have anyone, A and B and A are 2 separate things, but then there's half of that, in this case, ways to select them where the order doesn't matter. Okay, hopefully that's making sense. It's hard to explain. Okay, anyway, once you've got a feel for that formula, we can look at another problem and you just have to sort of trust the formula. So how many ways can 8 reindeer be selected from 15 reindeer applications? So I had to Google this. I thought Santa had 13 reindeer, but apparently he has 9 reindeer. I feel like Rudolph automatically gets a call up, so we're not worried about him. So he needs to select the other 8 reindeer from 15 reindeer applications. So you would say 15 choose 8 is 15 factorial on 8 factorial by 15 minus 8 factorial. And I'll show you how to calculate this if you don't have a CAS calculator handy. You come over to GeoGebra, make it a fraction. We need 15 factorial over 8 factorial by 15 minus 8 factorial, which is 6,435. And lo and behold, here's one I prepared earlier, 6,435. So there is 6,435 combinations of reindeer that Santa could select for his team of 8 reindeer. And remember, we divided through by 8 factorial. So that means having, Donna and Blitzen and having Blitzen and Donna is the same thing, right? We don't care about the order that they're in. Hopefully that makes sense. Good luck with all your studies and see you soon.